Solving for a specified variable. Solve for x. In this equation we have k equals to 3x plus 7y, and we have three variables, so there is no way for us to do order of operations and calculate a value. So the goal is to have this x all by itself. How do we solve an equation? We perform order of operations backwards. You would do additive or multiplicative inverses in reverse order of operations. So the only difference now is that you have to keep track of which variable you're solving for, and we are solving for this x. If it was any other equation and we had to solve for x, the first thing we would do would be additive inverse, and we have plus 7y, and the additive inverse would be negative 7y. Whatever you do to one side of the equal sign, you want to do the same thing to the other side of the equal sign. So now we have k minus 7y equals to 3x positive 7y minus 7y. These add up to 0. And now we are still solving for this x. So all we have to undo is multiplying by 3. And the opposite of multiplying by 3 would be to divide by 3. Whatever you do to one side of the equal sign, you want to do the same thing to the other side. So k minus 7y out of 3 equals 2x. This is our solution. And sometimes you might see x equals to k minus 7y out of 3, which is also correct solution. Just like if you have 7 equals to a, you can say a equals to 7. Solve for L. Here we have perimeter formula, P equals to 2L plus 2W. In this equation we are solving for this L. For solving, you always apply additive inverses first, so minus 2W minus 2W. We have P minus 2W equals to 2L. This adds up to 0. L is being multiplied by 2, so the opposite is to divide by 2. Whatever you do to one side of the equal sign, you want to do the same to the other side. This cancels into 1, and we have P minus 2W out of 2 equals to L. And this is our solution. But you might see L equals to P minus 2W out of 2, which is also correct answer. Here we have some three-dimensional geometry. Z equals to 25x minus 47y. We are solving for x. So the first thing to undo is the additive inverse. So we are minusing 47y. The opposite would be to add 47y. Whatever you add to one side, you want to add to the other side. Now we have z plus 47y equals to 25x. X is being multiplied by 25. The opposite would be to divide by 25. Whatever you do to one side of the equal sign, you want to do to the other side. This cancels into 1, and we have z plus 47y out of 25 equals to x. And this is our solution. You can see it as x equals to z plus 47y out of 25. We have e equals to mc squared, and we are solving for this m. Now it's being multiplied by c squared, and the opposite of multiplying by c to the second power is to divide by c to the second power. Whatever you do to one side of the equal sign, you want to do to the other side. Something divided by itself cancels into 1, so we have e out of c to the second equals to m. This is our solution. And you can see it as m equals to e out of c to the second, which is also okay. Solve for y. Here we have equation of a line. We want to do the additive inverse first, and the addition here is plus 3x. So you want a minus 3x. Whatever you do to one side, you want to do to the other side of the equal sign. This adds up to 0. So we have 7y equals 2. The only thing I want to do is rearrange order of this addition. This is positive 14. And the reason for it is that you're going to use that for graphing equations, and you would like to have variables come first. So I'm going to write negative 3x first and plus 14 second. Now we have y is being multiplied by 7. The opposite is to divide by 7. Whatever you do to one side of the equal sign, you want to do the same to the other side. However, when we start graphing equations, you want to divide each term, which is the same as dividing both sides. And the only difference this makes is for graphing that you will have slope and an intercept separately, not in one fraction. So we have 7 divided by 7, we have 1. Y equals to negative 3 out of 7x plus 7 goes into 14 2 times. And this is our solution. Just for practice, let's say we have 2y minus 7x equals to 18. Now we know that we are going to do additive inverse of negative 7x. But for graphing, we will want to have this x to be the first term on the other side of the equation. So in order to skip a step, I'm just going to mark down the sign of 18, which is plus, right? When we have no sign, that's a positive. And then I'm going to do the additive inverse. So the additive inverse of negative 7x would be to add 7x to both sides. So now we have 2y. This adds up to 0 equals to 7x plus 18. This skips the rearranging of terms later on. So y is being multiplied by 2. The opposite is to divide by 2. Whatever you do to one term, you want to do to all terms. You can put one big fraction, 7x plus 18 out of 2, but you also want to be able to do separate divisions, especially when we do graphing. 2 out of 2 cancels, and we have y equals to 7 out of 2x plus 18 divided by 2, 9. And this is our solution. That's all.